Welcome to The Explainer. Today we're going to tackle a really core economic idea, the production possibility curve. And we're going to do it by building a simple little economy from scratch. You'll see how it works, and we'll even uncover a surprising truth about unemployment along the way.
You know, this is one of the most fundamental questions in all of economics. And to find the answer, we're not just going to talk about theory. We're going to build a simple two-product economy right here from the ground up. Okay, so here are the building blocks of our hypothetical economy. It's simple. We've got 100 workers and 100 machines. And we can make just two things, wheat or milk. Now, the important part to focus on is the production costs. You can think of them like recipes. Making a ton of wheat is labor-intensive. It needs 2 workers, but only 1 machine. Milk, on the other hand, is the total opposite. It's machine-intensive, needing just 1 worker, but 2 machines.
So to figure out our economy's total potential, we're going to break it down and look at each resource one at a time. Let's start with our people, the 100 workers. For just a minute, let's pretend the machines don't even exist and see what our workforce can do all by itself.
So, first scenario, we put every single worker on wheat-making duty. We've got 100 people, and we know each ton of wheat needs 2 of them. So what's the absolute maximum we can possibly make?
Exactly. 100 workers divided by 2 workers per ton, that gives us a hard limit of 50 tons of wheat. So that's our first production limit, set entirely by our labor force.
All right, let's switch gears. What if we tell that same group of 100 workers, okay, forget the wheat, everybody is making milk now. Remember, the recipe for milk is different. It only takes 1 worker to make a ton.
Yep, pretty straightforward, right? 100 workers can make 100 tons of milk. So our labor constraint gives us a very clear trade-off. We can have 50 tons of wheat, or we can have 100 tons of milk. Or, of course, some combination between those 2 points.
Okay, we've figured out the limits of our people. Now, let's do the exact same exercise, but this time we're focusing only on our 100 machines. Let's just imagine for a second that the workers aren't even part of the equation.
All right, machines, your turn to make some wheat. If you look back at our little recipe table, making a ton of wheat only needs 1 machine. So with 100 machines ready to go, what's our limit?
You got it. 100 machines means we can produce a maximum of 100 tons of wheat, which is a completely different number than we got with our workers, right? That's interesting.
And for our last piece of the puzzle, let's see what happens when our machines are dedicated to making only milk. Milk, as we know, is the machine-heavy product. It needs 2 machines for every single ton.
So with 100 machines, we can make, at most, 50 tons of milk. So the machine constraint is either 100 tons of wheat or 50 tons of milk. Okay, so now we've got 2 different sets of limits.
So we have this limit based on our workers and a totally different limit based on our machines. But a real economy doesn't get to pick and choose which rule it follows. It has to respect both of them at the exact same time. So how do we put them together?
This really gets to the heart of it. An economy is only as strong as its weakest link, or in our case, its most limiting factor. Our true potential isn't what the workers could do or what the machines could do. It's the combined limit of both. At any given moment, we're held back by whichever resource we run out of first. And that combined limit, that inner boundary, that is our real production possibility curve, or PPC.
Now here's where this gets really fascinating. You might look at this curve and think that any point on that line represents perfect, 100% efficiency, with 0 wasted resources. But that's not the whole story.
Let's zoom in and analyze one specific point on this curve, the absolute maximum amount of wheat our economy can possibly produce. We already figured out that this is 50 tons, because at that point, we run completely out of workers. So now let's look under the hood and see which resources are actually being used to get there.
So to make those 50 tons of wheat, we need every single one of our 100 workers. The labor force is fully employed, maxed out. But that same 50 tons of wheat only requires 50 of our machines, which means half of our machines, 50 of them, are just sitting there, completely idle, gathering dust, even though we're operating at what we're calling maximum efficiency right on our production curve.
Well, this situation actually has a name. It's called structural unemployment. And it's not the kind of unemployment you hear about when the economy is in a recession. This is unemployment that happens because you've simply run out of a complementary resource. We can't use those 50 idle machines because we literally have no workers left to operate them.
So this is the crucial point to get. Regular unemployment means you're operating inside the curve. You're being wasteful.
But structural unemployment can happen when you are perfectly efficient right on the curve. It's a problem of a resource mismatch, not a problem of inefficiency.
So let's just do a quick recap of what we've discovered here. An economy's true potential is always defined by the inner limit of all its resource constraints. And, pretty surprisingly, pushing that limit to the max in one direction can actually create structural unemployment, where one resource is forced to sit idle simply because its complementary factor is totally tapped out.
There is, however, one magic spot on this curve. It's that point where the labor constraint and the machine constraint cross over. That intersection represents the one and only production mix of wheat and milk where every single worker and every single machine is fully employed. At any other point on our production limit, some resource is just sitting on the sidelines.
So, understanding these limits is absolutely crucial. It reveals hidden unemployment and shows us that maximum efficiency can still mean there's wasted potential. And this, of course, leads us to the next big question. If one country has a bunch of idle machines and another country has a bunch of idle workers, what happens when they start to trade? Well, that's where things get really interesting, and it's a key to understanding the entire global economy.